All right, guys, I'm back and I have moved into my living room. It's surprising how little light there is in this house. Okay, back to the sharing the screen. You'd think I'd get faster at doing this considering the number of times that I've done it now, but it doesn't really work that way. Okay, so we're still on objective 3. I thought I was done with it, but apparently not. And that we're starting to talk about factorial repeated measures design. So the word factorial, as you know, means more than one independent variable. So at least 2 factors or 2 independent variables are going to be in this design, although there could be more. And this is a repeated measures design. Repeated measures means that the same people are going to serve in every single condition. So let me give you an example of that. Let's see if I can get an example. Oh, there we go. So each participant is going to experience all levels of a particular factor. So for example, the participants would do these tasks this was an actual experiment. So they did all these tasks. What they did is name the number of numbers in each row. So in the first row, the correct answer would be 3. In the second row, the correct answer would be 2. In the third row, the correct answer would be 4. And in the fourth row, the correct answer would be 2. So you can kind of see what's going on. Sometimes there's interference. So for example, in number 2, you can see the interference there. The word is telling you 3, but there are only 2 numbers there, so it's easy to get it wrong. And this was a timed task, so they had the interference, and then they also had another factor, which was displaying as digits versus displaying as a written word. Okay, so let's look at this example. They presented one row at a time, and the first factor was the amount of interference, and there were 2 levels of that factor. There was either interference or no interference, and interference is when the number present doesn't match the number of numbers present. So the correct answer, for example, of 222, the correct answer is 3, and in no interference, it would be 2 there. The correct answer would be 2, exactly as it says. The second level, as I was mentioning before, is, the second factor or second independent variable is the presentation, whether it's in digits or words. That one also has 2 levels. So therefore, this is a 2-by-2 design. How many conditions does it have? Can you remember from our last video that this will have 4 total conditions? So let's take a look at those conditions. As I mentioned, 2-by-2 design is this type of design. So let's take a look at those conditions there. This one is a case in which a row is presented as digits and there was interference. So this would be something like 222 presented as, the numbers 22. Where's my camera? 222. Okay. And here then it would be words, TWO, 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 because again, there's interference. In this case, there's no interference. So this would be something like 22 presented as numbers, and here 22 presented as words. So no interference. And what we looked at is their reaction time here. So how quickly they could answer, whether it was throwing them off if there was interference or whether it was throwing them off whether there was words. So this is called a repeated measures 2-by-2 design. And the reason why is because every single person in the experiment got all 4 conditions. So each one of these, so if you were in this experiment, some of the lines might have been interference with digits, just like on the worksheet I just showed you. On the last page, some would be interference with words, some would be no interference with digits, some would be no interference with words. So different problems were depicting the different conditions, but each person was in all 4 conditions. Okay, so I want you at this point to think about, in this case, what are the main effects and how would you find them from the last video? Is there an interaction? Can you graph the interaction? Can you interpret the results there? So I want you to go back here and try to figure that out. I'll give you a hint. For the main effects, we're going to want to collapse those 2 for interference. We'll collapse these for non-interference, and then we'll collapse down here for digits and collapse down here for words. Okay. Let's take a look at the mixed factorial design. The mixed factorial design is when one of the independent variables is independent groups variable, given that it's randomly assigned, and one is repeated measures. So therefore we call it mixed because it's both. One is independent and randomly assigned, and the other is repeated measures. So we could do this by saying in an experiment, do students perform better alone or in groups? And that would be one independent variable. And then is performance affected by easy and difficult assignments? And that would be another independent variable. So let's look at how this is a mixed factorial. Students are going to work alone, and then the same students are going to work in groups. And that's your repeated measures independent variable, because we're doing it on the same students there. So same students are going to work in groups after working alone. Then what we're going to have is a between measures effect, where some students are going to work on easy tasks while other students work on more difficult tasks. And those are different groups there, so that's randomly assigned. Let's take a look at this. So as you remember, students are going to work individually, and then the same students are going to work in groups here. And then the task type, we're going to have difficult here, a difficult task, and then an easy task here. But now let's remember that the people who work on difficult tasks are a different group of people than work on easy tasks. These are the same. First they work as individuals, and then they work as groups. But only one group does the difficult task, and another group altogether does the easy task. So you might think in terms of how many people are in this experiment. So let's say that there are 25 people in this, in each one of the groups of this experiment. So you can imagine we had 50 people total in the experiment. We have 25 here who are working on difficult tasks and 25 who are working on easy tasks. Now remember that the 25 people here who did the difficult task as an individual that will then do the difficult task as a group. And the same here, the 25 people here, they're going to start with the easy task as an individual, but then they're going to do the easy task as a group. So they are repeating the individual and group measure, but they are going to both do the individual and they're going to do the groups. But they're going to either do difficult or easy tasks. So one of those is a repeated measures, and one of them is a independent groups. Okay, so I want you to think in terms of what are the main effects? Is there an interaction? Can you graph the interaction? So let's go back and look at that. If we wanted to look at the main effect of working as an individual, we would add 62 and 88. We would divide by 2. If we wanted to look at the main effect of working in groups, we would add 91, 41, divide by 2. And then we would be able to see, is it better? These marginal means here, if we calculated them, we could figure out, is it better to work in groups or is it better to work as an individual? And then the task type, we could also look at this, 62 plus 91 divided by 2, and that would be the effect of the difficult. And then 88 plus 41 divided by 2 would be the effect of the easy task. You could also graph out the interaction here by graphing all 4 of these numbers, as we saw in the earlier example on physicians. And that would be able to tell you whether you get that characteristic cross of the interaction. Okay, we're going to go on to the next one in the next video. Have a great day.